Okay, let's unpack this. Welcome to the deep dive. We have a fantastic stack of material here, taking a really close look at tropical sustainable architecture.
Yeah, it's a great topic.
Mm.
And it goes way beyond, just slapping some solar panels on a building in a hot place.
Oh, definitely.
These sources show it's actually a much more nuanced challenge, really.
They really do. So, our mission for this deep dive is, well, to pull out the most important insights from all this, understand the unique challenges because they are unique of building sustainably in the tropics,
hmm
and see some of the innovative approaches people are trying. Everything from like design theory down to materials and even how cities are planned.
And it's worth stressing those unique challenges, isn't it? We're
Right.
talking intense heat, yeah, but also crushing humidity, really powerful sun, heavy, heavy rain sometimes.
Completely different ballgame.
Totally different from, say, a cold climate where, let's face it, a lot of the traditional sustainable thinking came from. Focusing heavily on insulation, trapping heat in.
Right. So the strategies you need have got to be different. The goal here is to understand what makes sustainable architecture specific and, well, powerful in tropical areas. We want to pull out those key insights, maybe some surprising facts, from the material you've provided. So let's start with the basics then. What exactly is tropical sustainable architecture, according to these sources we've looked at?
Well, based on the material, it's defined as architecture that is enduring, empowering, and inspiring. Okay, fair enough. But the really crucial bit, I think, is that it must be appropriate.
Appropriate, how so?
Appropriate to the particular climates, the available resources, and importantly, the local cultures of the region. It's definitely not a one-size-fits-all thing.
Right. And you mentioned that contrast and strategies before. If insulation is king in cold places, what takes priority in the tropics?
Yeah, the sources are pretty clear on this. The main focus really needs to be on solar control, basically, keeping that intense sun off the building surfaces as much as possible.
Makes sense.
And then promoting natural ventilation. Getting air moving through the building is just paramount. Whereas, in cold climates, you're trying to stop air leaking out. Complete opposite, really.
That makes total intuitive sense. And the sources point to traditional or vernacular building elements as holding a lot of valuable wisdom here.
Oh, absolutely. Simple things, really, when you think about it. Like a rectangular layout, keeping the building fairly shallow so air can flow across.
Cross ventilation.
Exactly. Having openings on two sides. And then things like verandas, deep roof overhangs for shade. These were all methods that developed over centuries using what was available to cope with that climate.
It sounds like even the smallest details can have a pretty big impact.
They really can. I mean, beyond those big strategies, the sources mention things like ecological biodiversity, overall energy conservation, waste reduction. Those are critical too.
Uh huh.
But they also highlight that even surface details the color of a wall, its texture, the material itself, can make a significant difference in how the building performs, especially in managing heat gain.
How so? Like later colors reflecting heat.
Precisely. A dark, heavy material is just going to soak up more heat than a light, reflective one. It seems obvious, but it's a fundamental part of tropical design.
Okay, so let's shift gears a bit. Let's talk about that tension between the science and the art, the theory versus the practice in the field. Building science, it seems, tries to quantify everything, right?
Yeah, it aims to boil down environmental issues to numbers, things like thermal comfort indices, calculating heat gain,
They're a very analytical approach.
very much so.
Yeah.
But then you got the architect's design process, which is often much more holistic, more intuitive, maybe. It's about synthesizing lots of complex factors, juggling different criteria, often quite quickly, in a more qualitative way.
And therein lies the challenge, I suppose. Architects need to make design decisions efficiently. They don't always have the luxury, or maybe the time or resources during that fast-paced design phase, to run really complex bioclimatic calculations for every single option.
Exactly. Those simulations, figuring out exactly how a design will perform environmentally, they can be quite involved.
So how do you bridge that gap? How do you get the science informing the design without bogging designers down?
Well, one interesting idea presented in the sources is using what they call parametric studies.
Parametric studies.
Yeah, essentially it means running lots of computer simulations beforehand, sort of in the abstract, exploring how different variations in building form, orientation, materials, how they interact with climate conditions, how that impacts performance. You do this separately from a specific project.
Okay.
And then from all that data, you can generate general principles, maybe user-friendly graphical guidelines for architects. It makes that complex bioclimatic data much more accessible, more readily usable during the actual design process.
That sounds like a really smart way to translate the deep science into practical tools. The sources also bring up Dean Hawk's perspective on different environmental design modes. Could you walk us through those?
Yeah, Hawks talks about three main modes. First is the exclusive mode. Think of this as creating a totally artificial, automatically controlled environment.
Like a sealed, air-conditioned office building.
Precisely. A building that basically shuts out the external climate completely. Very common, obviously.
Everywhere.
Then there's the selective mode. This is the one that actively works with the environment. It uses the building's form, its materials, as the primary ways to control the internal climate. Mechanical systems like AC or supplementary only use when the passive strategies aren't quite enough on their own.
So the building itself does most of the work. It's the main filter.
That's the idea. And finally, Hawks mentions the pragmatic mode, which is where environmental design kind of happens more by chance, maybe inconsistently, often without a clear, deliberate strategy.
Right.
And the sources really emphasize that the selective mode is absolutely key for successful tropical sustainable architecture. It keeps the building envelope, the walls, the roof, the windows as the primary player in responding to the climate. And importantly, it integrates that technical function directly with regional identity, with culture. This is really where tropical design can and should shine.
Okay, that sets the stage nicely. Now, let's dive into some of those specifics, the case studies, and examples from the sources. We've got public housing in Singapore first, the Bedak Court example.
Ah, yes, this is a really fascinating one because it tackles a huge challenge. How do you create sustainable, genuinely livable spaces in high-rise, high-density tropical living, which is the reality for millions?
What were they trying to achieve there?
The goals were pretty ambitious. Things like reducing the reliance on air conditioning, cutting energy use and CO2 emissions, trying to lessen the urban heat island effect, get more greenery in,
Okay.
and also trying to bring some of the benefits people associate with landed living, having usable outdoor space, a connection to the outside into that high-rise setting.
Interesting. How did the design try to do that?
Well, the key solution highlighted in the sources is these quite significant semi-open forecourt spaces attached to the apartments. They apparently take up about 30–40% of the apartment area.
Wow, that's a lot.
It is. And these connect via what they call sky streets. And crucially, the whole thing was designed without AC being the default cooling method. The focus was really on passive design first.
And the findings from the study, how residents actually used these spaces and felt about them, they're pretty striking, aren't they?
They really are. The study found a really high frequency of social activities happening in those forecourts. Get this. 86% of residents use the space for things like having guests over, gardening, hobbies, more than once a week.
86%, that's huge engagement.
Isn't it? And thermal comfort was reported as pretty good too. 80% felt either slightly warm, comfortable, or slightly cool, which is impressive given the climate and the lack of constant AC.
Yeah, that's really good.
Daylighting was also rated well by 80%. And maybe surprisingly, 90% reported not feeling a lack of privacy, even though it's a semi-public kind of space. People seem comfortable.
And they also reported a strong sense of belonging, ownership, security. It seems the design did more than just manage the climate.
Exactly. The sources describe this really interesting sustainable cycle they observed. Basically, the comfortable environment created by the design encouraged more social activities,
Right.
which in turn fostered a better sense of community among the residents. And that led to people preferring the space, using it more, which then helps sustain that positive social and environmental atmosphere.
That's fantastic, like a positive feedback loop.
Precisely. It's a powerful demonstration of how social factors and environmental design can really reinforce each other.
Did the technical findings back this up? The environmental performance?
They did, yeah. They found that shade from the building's verandas and also integrated vegetation significantly cut down solar radiation hitting those forecourts compared to more exposed corridors nearby. And the plants themselves in the forecourts were found to lower the actual air temperature by up to nearly 2.5 degrees Celsius during warm periods.
Wow, plants making a real difference.
Definitely. The studies also look at the optimal size for these spaces. They found a threshold, around 2 meters depth measured from the access corridor, seemed to be needed for what they called a good zone.
A good zone.
Yeah, enough space for activities, comfortable environmental conditions, but also the right dimensions to sort of facilitate social interaction, those casual encounters as people walk by.
So they were effectively creating these usable, tropical streets in the sky, promoting comfort and community. That's a really key takeaway for high-density design in hot climates.
Absolutely.
Okay, let's move on to green building policy. We've got Taiwan and their EEWH system.
Right, and this example really highlights a critical point,
Mm.
the need to localize green building assessment tools.
What do you mean by localize?
Well, many of the big popular systems, LEED, BREEAM, you name them, were primarily developed for cold or temperate climates. Their criteria, the things they prioritize, they don't always translate directly or effectively to tropical or subtropical contexts. You can't just copy and paste.
Right, different priorities, like we said about insulation versus ventilation.
Exactly. So Taiwan developed its own system, EEWH.
What does EEWH stand for?
It stands for ecology, energy saving, waste reduction, and health. So, quite comprehensive and tailored to their specific environmental challenges and building practices, which is key.
And they included some really specific local indicators, didn't they?
They did. Things like water conservation, focusing on usage patterns and saving methods that make sense for their region, and, really importantly, they specifically addressed the massive amount of reinforced concrete construction waste in Taiwan. Apparently, it makes up over 95% of their construction market share.
95%, that's huge.
It is. So that's a major localized environmental issue they needed to tackle head-on in their rating system.
And what about energy saving? What did their findings reveal about the best strategies for the tropics?
Well, this reinforces what we were saying earlier. Their data showed that shading, through things like verandas, sun breaks, louvers, is significantly more effective for cooling in tropical and subtropical climates than strategies often pushed elsewhere, like just adding more insulation or using super high-performance glass.
So, again, control the sun first.
That's the message coming through loud and clear. They also mentioned some successful green remodeling projects in Taiwan, incorporating things like permeable pavements to handle rainfall better, and adding effective sun shading devices while still respecting the aesthetics of the original buildings.
Okay, shifting now to urban planning. We have the challenges highlighted in Dhaka, Bangladesh. The sources point to weak regulation as a major problem there.
Yeah, it seems weak regulation leads to a lot of unplanned growth, which puts pressure on historical sites, creates chaotic street life, partly due to things like unregulated street hawking.
And what's the consequence for the built environment itself?
A real scarcity of open spaces. Land gets rapidly turned into compact, high-density buildings, often without enough thought for breathing room.
Now, many cities use tools like floor area ratio, FAR, to control density and try to ensure some open space, right? For visual relief, maybe parks.
They do, and Dhaka uses it too. But the sources describe a significant conflict there. It seems the rules lack flexibility. Things like rigid setback requirements, exactly how far a building has to be from the property line, apparently prevent designers from creating the variety in open space and building form that you actually need.
Variety needed for what?
For environmental benefits, like ensuring good daylight gets into buildings, ensuring natural ventilation pathways aren't blocked, and also for social benefits. Designers struggle to meet the required density targets, the FAR, and create these beneficial varied spaces at the same time.
So the buildings end up
Packed too closely together, often in monotonous blocks, which compromises light, air, and the quality of the public spaces between them.
That sounds completely counterintuitive. Regulations meant to control things are actually hindering a healthier environment.
That's exactly the issue highlighted. The underlying problem seems to be a delay in adopting more nuanced, flexible regulations that understand these trade-offs. And also just a low priority given to the public realm, those essential open spaces, parks, squares, even just decent sidewalks with trees.
And this contributes to bigger problems.
Definitely. It contributes significantly to issues like the urban heat island effect, making the city even hotter. The key insight here seems to be that regulations need to be smart, flexible, and prioritize not just density numbers, but actual environmental performance and the quality of public space.
We also have these fascinating parametric studies mentioned, looking at really dense cities like Singapore and Hong Kong, analyzing how the actual shape and layout of the city, the urban morphology, affects the microclimate.
Yeah, this is using quantitative methods, computer modeling, to understand how things like density, street width, and the building skyline impact daylight and natural ventilation down at the street and building level.
What did they find for daylighting?
For daylighting, they measure it using something called VDF, vertical daylight factor, which relates to how much sky you can see. They found that varying building heights, creating random or stepped skylines, actually improved the overall daylight access significantly, something like 10–30% better compared to having buildings all at a uniform height.
Interesting. So uniform skylines are bad for light.
Apparently so, overall. Wider streets also significantly boosted daylight, as you'd expect, and higher density, perhaps obviously, drastically reduced it.
So a varied skyline, wider streets are better for getting light down into those urban canyons.
Yes, and the studies seem to suggest that the more difference in building heights, the better the overall daylighting. Now, for natural ventilation measured by air change rate, ACH,
How often the air gets replaced.
right. Street width again had a big impact. Wider streets, better ventilation potential. Varying building heights also improved the overall citywide ventilation. But interestingly, it had relatively little effect right down at the lower levels of buildings near the street.
Ah, so making the tops of buildings different helps airflow up high, maybe clears pollution better overall, but doesn't necessarily make it breezier when you're walking on the pavement.
That seems to be a key finding. And it ties into another related study mentioned, this one looking specifically at urban street canyons in Kuala Lumpur.
Okay.
That study suggested something slightly counterintuitive again, that deeper canyons with tall buildings close together might actually maintain tolerable thermal comfort for pedestrians longer.
How could that be? Less wind.
Well, the idea is the tall buildings provide more shade, reducing direct sun hitting the pavement, and they limit the view of the hot sky. So even if the wind speed within the canyon is lower, the reduction in solar radiation might compensate, keeping it feeling comfortable for longer periods.
Huh. Complex trade-offs.
Very. But that study also suggested that modifying the geometry and having varied building heights above the canyons could potentially improve both wind and temperature conditions, specifically at street level.
So it's complicated.
Extremely. The big takeaway from these urban studies is that designing for comfortable microclimates in really dense cities requires a very sophisticated understanding of urban form. You have to look beyond just averages and consider what's happening right down at ground level where people actually are.
Let's look at housing design again, this time in Hanoi's Old Quarter, with the traditional tube house model.
Ah, the tube houses. Hanoi's Old Quarter is famous for them. That high density, those very narrow, very deep houses, traditionally used as shop houses, often with businesses below and living above.
And they had traditional ways of making them work climatically.
They did. Crucially, these older forms often incorporated internal courtyards or light wells, voids within the long plan, specifically to bring natural light and ventilation deep into the building.
Smart. But I guess the modern challenge, like we see elsewhere, puts pressure on these traditional forms.
Exactly. There's huge pressure for more enclosed floor area, more usable square footage, which often means filling in those essential courtyards.
In the consequences,
A loss of that connection to the outside, to community life happening in the shared spaces. Poor internal environmental quality, dark, stuffy rooms. And then, inevitably, a heavy reliance on energy-guzzling AC and artificial lighting, which contributes to wider power supply issues in the city.
so how did the experimental house concept mentioned in the sources try to tackle this?
It proposed using something called basic space blocks, or BSBs, essentially modular units. The idea was to use these to create a more porous structure, maintaining internal wind corridors and voids for light and air.
Inspired by the old ways.
Directly inspired by the traditional courtyard features, yeah.
Hmm.
But adapted for modern construction methods and needs, trying to make something practical, energy efficient, and locally adaptable. The core idea is merging that old wisdom about airflow and light in the tube house form with new ways of building to cut down the need for mechanical systems.
Okay, finally, let's talk about innovative building materials. We have an example from Mexico, the EcoPet 21 system.
Right, and this project is really interesting because it tackles multiple interconnected issues that are common in tropical regions of many developing countries. You've got the energy crisis, a housing deficit, and environmental damage, often from waste.
And their approach is quite integrated.
Very much so. It combines bioclimatic design principles and sustainable technologies, sure, but also focuses on something very simple, very low cost, using local resources, recycling materials. And crucially, it couples this with supervised self-construction training.
Getting the community involved. And the key innovative material is recycled PE bottles, like plastic drink bottles.
Exactly, those ubiquitous plastic beverage bottles. They're available pretty much everywhere, often creating a waste problem.
So how do they use them in construction?
In a really ingenious way, actually. The bottles are filled with soil, sand, sometimes even concrete rubble, and then they're integrated within simple steel frames to create walls and even roofs.
Wow. What are the benefits of building with well-filled-up plastic bottles?
The sources list quite a few. They apparently provide pretty good insulation properties, which helps with the climate. They offer some seismic resistance. They're obviously very low cost compared to conventional materials.
Hmm.
And it can speed up the construction process,
So taking a waste product and turning it into a useful building block.
pretty much. And
Yeah.
it's not just the walls, it's part of a larger integrated system.
Yeah, you said it was integrated. What else?
Absolutely. The project aims to integrate other sustainable systems too. Things like solar energy for water heating, cooking, lighting, maybe small PV systems for electricity, potentially wind energy, on-site wastewater treatment, gray water recycling for gardens, rainwater harvesting.
The whole package.
Yeah, and promoting household gardens, even small-scale aquaculture or biogas production from waste. Plus, that supervised self-construction training aspect is key, and they mention specifically involving women and children, making it a real community-driven process.
That sounds incredibly holistic. It's addressing social and economic needs right alongside the environmental ones.
It really is. The sources emphasize these broader benefits, significantly cutting housing costs, creating local jobs and building skills, improving indoor comfort and the overall quality of life for residents, and reducing environmental damage by diverting all that plastic waste. It's a powerful example of how local resources and ingenuity can drive truly sustainable development that goes way beyond just the technical side of building.
So we've covered a lot of ground design theory, policy, specific building examples in different contexts, urban studies, innovative materials. But the sources also seem to push us to look beyond just the buildings themselves, don't they?
They do. They bring in that crucial socioeconomic dimension. It's a reminder that sustainable architecture isn't just a technical puzzle or an aesthetic one. It's deeply shaped by economic forces, by social trends, by policy frameworks. You can't really separate it.
And there's even a bit of a critique raised about some modern architecture called tropical.
Yes, there's a concern voiced in the material that some designs, maybe particularly in high-end projects or tourist resorts, might be more about achieving a certain style or marketability, getting that tropical look, rather than being about genuine ecological performance or deep social integration.
So potentially disconnected.
Potentially disconnected from the actual local climate needs, or maybe even from the lifestyle of the people who are meant to use the buildings day to day.
Hmm. This seems to tie into a larger, maybe more challenging question that the sources touch upon about the very nature of sustainability itself.
Yeah, it sort of asks, is sustainability itself sustainable in the long run if it doesn't actively engage with and maybe try to transform these broader socioeconomic, even political structures that fundamentally shape our cities and our buildings?
That's a big question.
It is. It's a challenge to think about sustainable design not as this isolated technical field, but as something deeply embedded within really complex societal systems.
Well, this deep dive has certainly shown us that tropical sustainable architecture is an incredibly complex, multi-layered field. It's not simple.
No, it truly requires integrating so many things.
Mhm.
That deep traditional wisdom we talked about, modern building science, definitely innovative materials and technologies, smart urban planning considerations,
And crucial.
and crucially, understanding the social and policy context you're working within.
It really seems to be about creating environments that are, to use those words from the definition, enduring, empowering, inspiring, and genuinely appropriate for their specific tropical setting, not just importing generic ideas from somewhere else.
Exactly right. And the examples we discussed today, from those high-rise forecourts in Singapore that actually build community, to using peat bottle walls in Mexico to create affordable, dignified housing, and even those urban analyses showing how something like street width really matters for comfort. They give us concrete insights into how this integration can actually be approached.
Okay, so let's wrap up with this. Here's a final provocative thought for you, our listener, to consider. How can the insights from these specific tropical examples, this focus on working with the climate, not against it, prioritizing natural systems like airflow and shade, integrating social needs into the design, utilizing local resources creatively, and thinking hard about urban form, how can all of that inform our thinking about sustainable design and urban living, no matter where we happen to be in the world?